So we're here at the example table, and in this video we're going to find the zeros of the function 3x times 2x minus 3 to the negative 2/3 plus 4 times 2x minus 3 to the 1/3. So remember, when you're finding a zero of a function, you want to find a value of x such that f of x equals 0. Now when you look at this formula, you might think, well, both of these terms being added together have this 2x minus 3 in there. So you could say, well, if you plug in x equals 3/2, this becomes 0 and this becomes 0, so that would be a 0 of f. But you have to be careful anytime you have exponents like this, because here we have a negative exponent, which means this whole term is really something going on in the denominator, and we can't make the denominator 0. So we have to be careful about that. So let's rewrite this function and see that a little bit more clearly. So we get 3x times 2x minus 3 to the negative 2/3 plus 4 times 2x minus 3 to the 1/3. In fact, it's not maybe quite as clear as if it would be if we didn't have these fractional exponents, but we can factor out a 2x minus 3 to the negative 2/3. So we write 2x minus 3 to the negative 2/3 times some quantity. Now what remains from this first part? We've taken out this whole thing, so all that remains is a 3x. What about the second part? Well, we have a 4, so we're going to have plus 4. But now whatever we multiply 4 by in these brackets, it needs to that term needs to multiply by this guy, 2x minus 3 to the negative 2/3, to give us 2x minus 3 to the 1/3. And that quantity is just 2x minus 3. So remember, 2x minus 3 without an explicit exponent, well, it really means that there's a 1 in the exponent. And if we multiply this by this, then we add the exponents. So 1 plus negative 2/3 gives us 1/3. So these two things are equal. And let's rewrite this a little bit more. We're going to put this whole thing in the denominator. Because this negative exponent we can turn positive if we throw it in the denominator. We get 2x minus 3 to the 2/3. And then this top part, let's simplify. We have 3x plus 4 times 2x. That's 3x plus 8x. So we get 11x. And then we have a minus 3 times 4, so minus 12. Now, it should be a little clearer that we can't plug in 3/2, right? Because that would make this denominator 0, and that's no good. So we want to solve for this thing, solve for x when this thing equals 0. A ratio equals 0 exactly when the numerator equals 0 and the denominator doesn't. So 11x minus 12 equals 0. Move the 12 over, we get 11x equals 12. Divide both sides by 11, we get x equals 12 over 11. The only thing we need to verify is that 12 over 11 does not make the denominator 0. Well, the only way to make the denominator 0 is to plug in 3/2. So we know that this can't make it equal to 0. But let's just make a note of that. Denominator at x equals 12 over 11 is 2 times 12 over 11, so that's 24 over 11 minus, it's minus 3, but let's put everything over a common denominator, so this is minus 33/11 to the 2/3. This quantity inside here is not 0, so raising it to the 2/3 power is also not 0. So the denominator is not 0 also. Sometimes we can consider this a parenthetical remark if it's really obvious, but it's usually worth noting. So x equals 12 over 11, numerator is 0, denominator is not 0, so this is our solution.